Hello everyone and welcome back to Mathematical Mindsets. Right here we have this ninth exponential algebra problem, and the question says 8 raised to the power of x plus 27 raised to the power of x divide 12 raised to the power of x plus 18 raised to the power of x, and this is equals to 7 over 6, and we are to find the value of x. Now we can easily rewrite it in terms of 2 as 2 raised to the power of 3 or raised to the power of x, plus 27 can be expressed as 3 raised to the power of 3 or raised to the power of x, divide. We know that 12 is 4 multiply 3, and 4 can be expressed as 2 raised to the power of 2 multiply 3. Okay, so in place of 12 raised to the power of x, we are going to have this to be 2 raised to the power of 2 multiply 3 or raised to the power of x, plus, but 18 can be expressed as 2 multiply 3 multiply 3, which is 2 multiply 3 square. Okay, so for 18 raised to the power of x, we are going to put 2 multiply 3 raised to the power of 2 or raised to the power of x, and this is equals to 7 over 6 right here. Okay, so from here we want to simply apply this property to the denominator. That says if we have a multiply b or raised to the power of m, this is equals to a raised to the power of m multiply b raised to the power of m. So applying this property, we have this to be 2 raised to the power of 3 or raised to the power of x, plus 3 raised to the power of 3 or raised to the power of x, divide. Now for the denominator, we have this to be 2 raised to the power of 2 or raised to the power of x multiply 3 raised to the power of x, plus 2 raised to the power of x multiply 3 raised to the power of 2 or raised to the power of x, and this is equals to 7 over 6. But from the property of exponents, if we have a raised to the power of m or raised to the power of n, now this can easily be arranged as a raised to the power of n or raised to the power of m. So applying this, we have this to be 2 raised to the power of x or raised to the power of 3, plus 3 raised to the power of x or raised to the power of 3, divide 2 raised to the power of x or raised to the power of 2 multiply 3 raised to the power of x, plus 3 raised to the power of x multiply 3 raised to the power of x or raised to the power of 2, and this is equals to 7 over 6. So I'm going to say suppose 2 raised to the power of x is equals to a and 3 raised to the power of x is equals to b. So hence we have the expression to be a raised to the power of 3 plus b raised to the power of 3, divide a raised to the power of 2 multiply b, plus a multiply b raised to the power of 2, and this is equals to 7 over 6. Applying the sum of cubic formula, that says if we have a raised to the power of 3 plus b raised to the power of 3, this is equals to a plus b multiply a square minus ab plus b square. So applying this formula right here to the numerator, we have this to be a plus b multiply a square minus ab plus b square, divide. Now for the denominator, we have ab to be common, so if you factor out ab to be common, from here we have this to be a plus b, and this is equals to 7 over 6. So this is going to cancel out this, so we have a square minus ab plus b square, divide ab, and this is equals to 7 over 6. So separating this fraction, we have a square divide ab minus ab divide ab plus b square divide ab, and this is equals to 7 over 6. So from here we have that a is going to cancel out this, so we have a over b minus ab is going to cancel out ab, so we have this to be 1, plus b is going to cancel out this, so we have this to be b over a, which is equals to 7 over 6. So collecting like terms, we have this to be a over b plus b over a, and this is equals to 7 over 6 plus 1. So from here we have a over b plus b over a is equal to, look for the LCM, we have this to be 6. 6 divides 6, 1 times 7 is 7, plus this is over 1, so 1 over 6 is 6, 6 times 1 is 6. So we have a over b plus b over a is equals to 7 plus 6 is 13 over 6. So right here we want to say suppose that a over b is equals to y, then we have the inverse, which is b over a, to be equal to 1 over y. So applying this right here, we are going to have this to be a over b is y, so we have y plus 1 over y, and this is equals to 13 over 6. So from here we look for the LCM, we have the LCM to be y, this is over 1 into y is y times y, we have y squared plus y into y1, 1 times 1 is 1, which is equals to 13 over 6. So from here we easily cross multiply. So if we cross multiply, we have this to be 6 multiply y squared plus 1 is equals to 13y. So we have 6 times y squared will give us 6y squared plus 6 times 1 is 6, which is equals to 13y. Rearranging this right here, we're going to have this equation to be 6y squared minus 13y plus 6, and this is equals to 0. So factorizing this, we're going to take this and multiply it with the last one. So multiplying this, we have this to be 36y squared. So you look for a number that when you multiply them, it's going to give you 36, and when you subtract them, it's going to give you 13, and we have that to be minus 9y and minus 4y. If you multiply minus 9y times minus 4y, we're going to have 36y squared, and if you add minus 9y minus 4y, it's going to give us minus 13y. So in place of minus 13y, we are going to add in minus 9y and minus 4y. So hence, we have this equation to be 6y squared minus 9y minus 4y plus 6, and this is equals to 0. So if we factor this out from here, we have that 3y is common. So if 3y is common, we have 2y minus 3 left. Then from here, minus between 4 and 6, we have 2 to be common. So we have 2y minus 3 equals to 0. So we have 2y minus 3 multiply 3y minus 2, and this is equals to 0. So from here, we have that 2y minus 3 is equals to 0. And we have 3y minus 2 is equals to 0. So we have 2y is equals to 0 plus 3. 2y is equals to 3. So divide both sides by 2 right here. This is going to cancel out. So we have y is equals to 3 over 2. And from here, we have that 3y is equals to 0 plus 2. And we have 3y is equals to 2. So divide both sides by 3. This is going to cancel out this. We have that y is equals to 2 over 3. So we have y equals 3 over 2 and y equals to 2 over 3. But we want to simply recall at the beginning we said that let a over b be equals to y and b over a be equals to 1 over y. So from here we have that a over b is equals to 3 over 2 and b over a is equals to 2 over 3. Also, recall that suppose that 2 raised to the power of x is equals to a and 3 raised to the power of x is equals to 2. So we have that 2 raised to the power of x is equals to a and 3 raised to the power of x is equals to b. And from here, we have that a over b is equals to 3 over 2. So we have a is equals to 2 raised to the power of x and b is equals to 3 raised to the power of x, right? From this, so applying this, putting this into this equation, we have this to be 2 raised to the power of x divided 3 raised to the power of x is equals to 3 over 2. And if we have this property that says a raised to the power of m divide b raised to the power of m, this is equals to a over b all raised to the power of m. And we know that 1 over a can be expressed as a inverse, right? So we're going to apply this to the left hand side and apply this right here to the left hand side. So for the right hand side, we have this to be 2 over 3 all raised to the power of x is equals to, so if you take the inverse of 3 over 2, we're going to have 2 over 3 all raised to the power of negative 1. Now, since the bases are the same, all we have to do is to equate the power. So therefore, we have that x is equals to negative 1, and we have the first value of x. So we have been able to solve for a over b equals to 3 over 2. So from here, we want to simply solve for a over b, which is equals to 2 over 3, and we have that a is equals to 2 raised to the power of x and b is equals to 3 raised to the power of x. So from here we have that 2 raised to the power of x divided 3 raised to the power of x is equals to 2 over 3. Alright, we want to simply apply this property that says if we have a raised to the power of m divide b raised to the power of m, this is equals to a over b or raised to the power of m. So applying this, we have this to be 2 over 3 all raised to the power of x is equals to 2 over 3 all raised to the power of 1. Now, since the bases are the same, all we have to do is to equate the power. So we have that x is equals to 1. So from here, we have that the values of x to be, now the first value of x is negative 1 and we have this to be 1. So guys, we have been able to solve this ninth math problem right here. So with this guys, I'm going to see you in the next video.